Hello, my name is Pavel, and today I'm going to explain LeetCode problems the number of beautiful subsets. Here we are given an array nums of positive integers, and we should return number of subsets that are beautiful. And here we have a definition of beautiful subset. So a subset is beautiful if it doesn't contain two integers with an absolute difference equal to k. So let's look at example first to understand the problem clearly. 2, 4, 6 and k is 2. So it's obvious that each number itself is a subset that is beautiful. So we have 3 beautiful subsets here. Plus we can take a subset of 2 and 4 just because difference between them is equal to 2, and same for 4 and 6, but we can take 2 and 6. So I would solve this problem by applying backtracking technique. So it's about trying to find right candidate, check condition of current state, and if state is valid, we just increment count. So for example, we would go one by one, and for example at the start we have 2 options: add our current element to subset or not. So for example, we add 2. After that, on the left side, as far as we put to subset nothing, we just so let's say it's nothing here, subset is empty. We could put 4 or nothing. Here same, we can put 6 or nothing. So, and here we can see that we have single elements in subset, and we can check for validity and make a decision that it's a valid subset and it's beautiful. That's why we do some +1. So from that point where we have 2, we have 2 options: add 4 to get 2 and 4 in our subset, but just because we have a constraint before check of adding 4 to our current subset, we just decide that it's not valid. So we have another option, just leave 2 as a current subset. So from that point it's finished. We add end of the loop just because we just rejected. Here we have an option to add 6, and it would be valid subset, and we could leave 2 without any option. So it would be at the end of our loop. So here we have an option with 4 add. It's a bit messy, let me redraw. To the right side. Here is empty. We could add 4 or empty, add 6 or empty. So from 4 we can add 6. It would be subset of 4 and 6, but it's not valid. We wouldn't add count. Or we can leave 4, and at the end we could leave 4 or nothing. Yeah, so it's just finished here. So here we have empty and 6 and empty, and at the end of our initial array. So here we have 1, 2, 3, 4. So in code, we should just check before increase elements in our subset about validity. And here is an important detail. While solving this problem, I'm just thinking that I could use last element from my current subset and just do some just find absolute difference between my current value that I could add and my previous last element in my current subset, just because first of all I could sort my so if it wouldn't be sorted at the start, we could do that by our own. So for example, if we would provide it with such array, we could sort it with 2, 4, 6, and so we just initially sorted. For example, it's important to check not only difference between last element of current subset and current elements that we want to add to current subset, but also with all elements. So just because k could be, for example, 3, and for example my current subset is about 1 and 5, and difference between them is 4, that's why it's valid. But for example, if I want to add something like so I think it's not very sorry, it would be something like if we have a sorted array, it could be something like 2, and for example I want to add 4, and if I will compare only 2 last elements, it's my current position that I want to add, and it's my last element in subset. It would provide difference of 2 that is not equal to 3, and I could do some error here, mistake. So that's why I need to check for all elements in my current subset to identify validity of adding 4 to my current subset. So in code I just show you how to do that, and let's go to code. Okay, let's do it in code. So as I said, in whiteboard, first we need to sort our initial array, just because we don't have such information about it's sorted or not. It's important. After backtrack, we would use backtracking, and here we should provide our num k. We should add new array list for storing current state, and plus we would provide initial position that we would increment for each step. Private backtrack our array, okay, list for current state, and start position. So first we initialize count with null 0. After that we go through our initial array from position of start till the end. Okay, and return count. Here we should identify, is it possible to add our current element at the position I to current state, and we could do that by the following: introduce variable. Okay, so it's without mistake. So we're thinking that it's true by default, and we will just go through our current state with nums current and check absolute difference between current element in state and our current element. And if it's equal to k, we just consider that it wouldn't be beautiful. That's why it should be false. And here, if our variable is true, it means that we could add. So for example, for the first step, it wouldn't execute this loop, and we just simply add to our current state our initial first element, current add nums I. After that, as far as we add, we can increment our count, and at the same time we could do for our next element nums k current and I plus 1. And to cover our right side, we should just remove our current element, current -1. So we just remove last element that we add previously. Okay, everything is fine here. Array, okay. I'm a little bit tired. Too much errors, lengths. Okay, it's only for string. Okay, it's not very efficient, but I think it could be much more faster, but it's working. Okay, time complexity for this solution would be 2 power n, just because we track current element, and we add this element or not add. And that's why we got two options and going through the loop of n, and that's why it would be 2 power n for most backtrack solutions. And for space complexity, we would have a stack trace of O of n, just because we have a loop from 0 to n. So again, times complexity is 2 power O n, and space complexity is O of n. So thank you for watching and have a nice day.